Okay, now that we have the percent mass of iron, how does this help us determine what our compound we made is? Okay, so let's go to our ratio. So we give you that the percent by mass of oxalate is 53.75%, and we've just determined that the mass of iron in this system is 17. Okay, so what do we want to do then for the system? Okay, let's assume we have 100 grams of material. Okay, so if we assume we have 100 grams of material, how many grams of our material is made up of iron? Well, since it's 17% is made up of iron and we have 100 grams, it winds up we have 16.99 grams of iron. And ironically, we also have 53.75 grams of oxalate in that 100 grams. So now, out of curiosity, how many moles would that be? Well, it's quite easy to see that we take the number of grams, we would then divide it by the molecular weight, and you'd see that we have 0.03 grams of 0.304 moles of iron. And here we would take our oxalate, divide it by molecular weight of oxalate, and you'd see we have 0.61 moles of oxalate. Now, what we want to do is figure out the ratio between the two, right? The empirical formula. So we're going to divide these by the smallest number. So this would be divided by itself to give us a 1. And then this cell would be divided by the smallest one again, which would be this one. And so basically our ratio, once we round, would be 1 to 2. Okay, so in our system of potassium, iron, oxalate, water, we would have 1 iron to every 2 oxalates. Okay, cool. So what about the charge? The charge on iron is 3, and the charge on each oxalate ligand is -2. So net charge for each one of these is just basically the ratio times the charge. And so our total charge would simply be the sum of those two -1. Since this is a neutral compound, right, we have to have a balance in charge. Water is neutral, so that's not gonna work with -1. But potassium is a +1 charge, so potassium now is a 1. If you do your calculations and for some reason come up with a positive charge, then you'd set potassium equal to 0. That's only if you have poor data. More often than not, it's going to come up as negative. Okay, so what do we do from here? Well, let's figure out what our weight for this system would be if we assume 100 grams. Because if we also assume 100 grams, we would have a potassium, right, percent mass. Because it's a 1 and iron's a 1, it would have the same number of moles, right? And we can go backwards to figure out what this mass would be, since this is simply the amount of grams divided by the molecular weight. We can then easily go the opposite direction and say it's this times the molecular weight in order to get the percent mass by weight of potassium. Okay, so now we have the percent mass by weight of potassium, and we know that our whole system has to be 100 grams. So if I have 100 grams, and 16 is coming from iron, going to minus that, and then 53 is coming from oxalate, minus that, and we have 11.9 coming from potassium, I'll minus that. We have some percent mass that we have not accounted for, 17% mass. And so that is going to come from the H2O. In order to figure out how many moles there are, we'll simply take this number and divide it by the molecular weight of water, and we will get the number of moles. This is the number of moles of water. To figure out the ratio, you figure that one out as 1. To figure out the ratio, we'll just simply take this number and divide it by the smallest number of moles, which is this, which will give us a value of 3.16, which will round down to get 3. So now our molecular weight, or our molecular formula, will be 1 potassium, 1 iron, 2 oxalate, and 3 water. What does this give us? Well, this gives us a molecular mass. So if we have 1 potassium times its molecular weight, and we have 1 iron times its molecular weight, we have 2 oxalates times their molecular weight, and we have 3 waters times their molecular weight, and we sum these together, we now have the molecular weight of the compound.